Welcome to the next lesson from section 7.5. I've added a blue background. I'm hoping that'll cut back on the glare. I also have a light blue background. I'm not sure which is going to provide more or less glare. I think this is probably the better alternative, but that remains to be seen. We're going to take a look at simplifying what's called complex rational expressions. This is going to be spread over 4 videos to look at 4 types of problems that we'll encounter in this section. So let's take a look at what we mean by complex rational expressions. First, we're going to take a look at number 5. So this is going to be 1 over 2 plus 1 over 3 divided by the quantity of 1 over 4 minus 1 over 6. So as if fractions weren't complicated enough, we begin to embed fractions within other fractions. So what we're going to try to do to help resolve this is we're going to try to get rid of the fractions at least in the numerator and the fractions in the denominator. What I encourage you to do also is to copy this question down before I begin to do work on this so that you can write this question separately. So copy this portion down twice, and then the second time you copy this, do the work that I'm about to do. Remember, you can pause this video. Please take advantage of that. So what I'm going to do to help simplify this is I need to multiply the top fractions and the bottom fractions by some quantity. And it should be the same quantity. So what I'm looking for 2, for 3, for 4, and for 6 is I am looking for the least common denominator for all of those numbers, or the least common multiple for all of those numbers. Because what I'm going to try to do is actually clear out the denominator. So I'm not going to try to get these denominators to be the same so that I can add the fractions top to bottom. That's not where I'm going with this. What I'm actually going to try to do is to try to get rid of the fractions, but yet maintain the equality of the complex rational expression. So I find for 2, 3, 4, and 6 the least common denominator or the least common multiple. Now, we looked at techniques for this before. So if I'm looking at 2, 3, 4, and 6, and most of these are not real intricate, so that's why you see me just kind of writing these out. Well, 6 is a multiple of 2, 6 is a multiple of 3, but 6 is not a multiple of 4. So if I can write out 2, 4, 6, 8, 10, 12, let's write out for 3. 3, 6, 9, 12, 4, 8, 12, 6, and 12, we see that they all have the least common multiple of 12. So what I'm going to do, and I'll write this again, is I'm going to multiply the entire top portion by 12 over 1. Again, if you did not write this down the first time, I encourage you to write this down with all this additional work, and then write this fraction down again a second time before I begin to show this work. I will show the next step of this and what that's going to look like. So I'm going to distribute. I'm going to distribute 12 through this. So watch how I do this now. So I'm going to take 1 over 2 plus 1 over 3 over 1 over 4 minus 1 over 6, and I'm going to multiply each of these portions by 12 over 1. If you hear that car alarm in the background, my apologies for that. I'm not sure if you hear that or not. So now what we're going to do is we're going to multiply each of these through and see what we get as a result. So we have, see, 2 will, let's see, if I have 12 divided by 2, that's going to go in 6 times. So we have 6 times 1 is 6. That'll give us 6. 12 over 1 times 1 over 3. 3 goes into 12 here 4 times. So that'll give us 6 plus 4. Here we have 12 times 1 is 12. 1 times 4 is 4. 12 divided by 4. This is going to give us 3. Here we have 12 over 6. 6 is going to 12 2 times. 2 times 1 is 2. 1 times 1 is 1. So this is going to be minus 2. So what we've done at this point is we have chosen a number, that number is 12, that's in red, to multiply all of these fractions by, so that instead of fractions, we now replace these quantities here with the whole numbers that we see present to the right. And as we look at this now, we can simplify this by saying 6 plus 4 is equal to 10, 3 minus 2 is equal to 1, and 10 divided by 1 will be 10. So the quantity of 1/2 plus 1/3 divided by the quantity of 1/4 minus 1/6 gives us a value of 10. So make sure that if you need to watch this a few times. The work is going to get a little more complex, and not that the work is difficult, it just is tricky, and it's easy to slip up and make a mistake. Let's take a look at another problem. And we're going to look now, I will get rid of this paper since I used my marker. We're going to go ahead and look at question 13. And I will write it as such. So this is going to be 5 over a minus 4 over b divided by the quantity of 2 over a plus 3 over b. And let's see how much we can go ahead and simplify that. So as we look at the terms in the denominator, and I'm going to try to find something that doesn't quite leak through so badly. So if I look at the a, the b, the a, and the b, I realize that the least common denominator, least common multiple for this is going to be a times b. So I'm going to multiply the top and the bottom by a times b over 1, or ab over 1. So I'm going to keep distributing this for a while, but eventually I'm not going to distribute this through every single time. This is a procedure you should get comfortable with, and hopefully you can develop some mental aptitude for this. So what I'm going to do now is I'm going to rewrite the same problem. And remember, if you need to copy this problem down in 2 steps so that you see the original problem and see the word that's done to it, please do so. So this will be 5 over a minus 4 over b over 2 over a plus 3 over b. So I'm now going to go ahead and distribute a, b over 1 to each of these. Oops, and that's not D, that's A, B over 1. Okay, and I know that's a little light, but that should be visible for what you're looking at. So what we do now is we try to simplify. Let me use my other pen here. We try to simplify this as much as we can, and in some degree it's actually easier to see this with variables because the simplification is pretty concise. So I want to simplify this to one term now. So I'm going to have the a's reduce, and all I have is b times 5. Well, this is going to give me 5b. We have a minus sign here, and that's not going anywhere. I'm going to try to simplify this now to one term. And here, because we have a b on the top of the bottom, these reduce. We have a times 4. And notice here, there's nothing left at the bottom. And that's what we're going for. You want to eliminate the bottom here. We have a times 4. That's going to be 4a. In the bottom here, we can reduce the a's. We're left with b times 2, which is 2b. Then plus, I'm going to simplify this here, reduce the b's, and we're left with a times 3, and yes, that's an a, just to clarify. A times 3 is going to be 3a. So when we multiply this through and clear this out, we have the quantity of 5b minus 4a over 2b plus 3a, and there's nothing we can do to factor or simplify that any further. We're simply going to retain this as a final answer of 5b minus 4a over 2b plus 3a. Let's keep going forward with another question in this area. I think I can use the back side of this sheet. I think that'll be okay. Let's go on to question number 18. And let's see what this looks like. So this is going to be x squared minus y squared over xy divided by the quantity of x minus y over y. So what I'm going to do now is I'm looking at the denominators in the top fraction and the denominator of the bottom fraction. So I'm looking at this denominator and I'm looking at this denominator. And when I look at the denominators of x and y, and I look at the denominator of y, I see that the least common multiple of these is simply going to be xy. This has an x and y, this has a y. So I'm going to multiply the top and bottom of both of these by xy over 1, and then xy over 1. What's nice about this at least is we only have one fraction in the top, in the numerator, and we have one fraction in the denominator. What's even nicer about this part is, once I multiply everything through, I actually cross out the x and the y, and on top, let me just cross this out here, I'm left, once this reduces, I'm left with simply the quantity of x squared minus y squared. Here, I'm left with, I can reduce the y, and I'm left with the quantity of x times x minus y. At this point, we've eliminated the fraction in the numerator of the complex fraction, and we've eliminated we've eliminated the denominator in the top fraction, and we've eliminated the denominator of the bottom fraction. So now we have a simplified fraction, not the complex one we had before. So once we get to this point, we have to see, is there any further factoring that we can do to try to simplify this? And in fact, there is. The top is the difference of perfect squares, which I can express as x plus y times x minus y. And the bottom I can just leave as is because it can't be factored further. And when I look at the fraction in this form, I realize, well, x minus y can be reduced. And my final answer here is going to be simply x plus y over x. And that's my final answer in simplified form. Let's go ahead and take a look at some other types of factoring that involve trinomials. Or binomials, I should say at least. Taking a look now, backing up a little bit at number 11. So here we have the quantity of x plus 2 over x minus 1 divided by x plus 4 over x minus 3. So as we look at these denominators, sorry about that, guys, that was my phone here. So as we look at these denominators here of x minus 1 and x minus 3, going back to this, I waste two sides, but boy, it sure looks a lot nicer. These don't have anything in common. So the best I can do for a common denominator is simply the product of these. So what I'm going to go ahead is I'm going to multiply the top and bottom of each fraction by both of these. So I'm going to multiply the top of this by x minus 1 times x minus 3 over 1. And the bottom one I'm going to multiply by x minus 1 times x minus 3 over 1. So I am picking this because for x minus 1 and x minus 3, the product of this is the least common denominator for both of these. So watch what happens as I begin to distribute this through. Again, when you're copying these questions down, I would encourage you to copy the original problem. Copy the original problem again, showing this work. And then if you want to copy the problem again in this state and then show how the reduction works, that will be fine too. So once I have it in this form, let's see what I can reduce. Well, I have x minus 1 here. I have an x minus 1 here. I can reduce that. The idea is I need to get rid of the denominator. This does it. So that's going to leave me on the top. Well, let's get back to that in a moment. I have x minus 3 in the denominator here. I have x minus 3 in the numerator here. I now get rid of the denominators in the bottom fraction as well. So only by multiplying by x minus 1 times x minus 3 does that enable me to get rid of both denominators in both parts of the complex fraction. So once I do that, I'm left with, on the top, the quantity of x minus 3 times x plus 2 over the quantity of x minus 1 times x plus 4. And at this point, this is as far as you need to take this. You've already done factoring. You are not trying to multiply this together by foiling. You may leave it in this form. That's going to be the expectation. And I think I need to make that perfectly clear. You don't need to do anything else with this other than what's done here. Let's take a look at another problem. We're taking a look now at question number 23. So we have 1 over a minus h minus 1 over a divided by the quantity of h. So in this question here, we only have fractions with, okay, so if we're looking at this, only the numerator of the complex fraction contains fractions. The denominator of the complex fraction does not contain a fraction. So what we're going to try to look to eliminate is the quantity of a minus h here and the quantity of a here. So we're going to look to see what the least common denominator of these two fractions are. Since they have no factors in common, we are going to multiply the top and the bottom, because what we do to the top we have to do to the bottom. I'm going to need to multiply the top by the quantity of a minus h times a over 1. And even the bottom, I have to multiply it by the same thing, a minus h times a over 1. And if it helps, we're going to go ahead and put a 1 there if you need that. So what's going to happen, and I will expand this, is let me expand to see how we distribute this across the top. So I'm going to make that a little bigger here. This is going to be the quantity of a minus h times a over 1 minus times 1 over a minus h minus the quantity of a minus h times a over 1 times 1 over a. This is going to be divided by the quantity of a minus h times a over 1 times h over 1. So let's see what we can do to simplify this now. First, we will here in this portion be able to eliminate a minus h. In the second part here, we're going to be able to eliminate just the a. So what we have here is a times 1. Well, that's simply going to be a. Here we're going to have minus the quantity of a minus h. On the bottom here, we're going to have a times h times a minus h. So let's see what happens across the top here then. So on the top here, we're going to have a minus h. So we need to distribute this through the top. So I'm going to go ahead and write this down below again. So we have a minus the quantity of a minus h over a times h times a minus h. When I distribute this negative through, it's going to give me a minus a plus h over a times h times a minus h. Well, a minus a, that's going to reduce to 0. That's going to leave me with h over a times h times a minus h. Now that we have h by itself, nothing being added or subtracted from it at this point, we can also reduce the h here. And that's going to leave us on top with 1 over a times a minus h. And that is our final answer for question 23 in its simplest form. We'll take a look at a couple more questions for this video and see how this gets more difficult as we expand upon this. We're looking at now question 25. And it's going to be the quantity of a squared minus 4 over a to the second plus 3a plus 2 divided by a to the second minus 5a minus 6 over a to the second minus 6a minus 7. So, one technique that we haven't explored yet with a question like this is, can we do anything to start with to simplify this problem so we're not going to have to do so much work with finding a common denominator? And fortunately, the answer to this is yes. Within the numerator and the denominator itself, by simplifying each of the rational expressions, by simplifying the rational expression in the numerator and simplifying the rational expression in the denominator, we should be able to produce a complex fraction, but a less complex fraction. So let's take a look at each part. So what I'm going to do is I'm going to simplify this, but I'm going to wait to put this here. I'm going to bring, by the way, if you need to copy this again, go right ahead. But I'm going to bring this work down below and see what I can do to simplify it. So if I have a to the second minus 4, well, that's the difference of perfect squares. So I'm going to write the factors of this as a plus 2 times a minus 2. For a to the second plus 3a plus 2, I can write the factors this is a plus 2 times a plus 1. Well, I can eliminate a plus 2, which is going to leave me with a simplified version of this rational expression on top as a minus 2 over a plus 1. And that's what I'm going to put back here because a minus 2 over a plus 1 is equivalent to this more complex rational expression here. Now, let's take a look at simplifying the bottom. Again, I'm not showing the factoring techniques for this. I'm just going right to the factors. This is something you should be comfortable with, and if you are not comfortable with it, please refer to Chapter 6 for further assistance. So for a squared minus 5a minus 6, my two factors are going to be a plus 1 times a minus 6. For the bottom one, a squared minus 6a minus 7, it's going to be a plus 1 over a minus 7. So in these two factors for the top and the bottom, we can reduce a plus 1, and now I can rewrite this rational expression as a minus 6 over a minus 7. Now that we have this simplified, we have to consider how can we get rid of these denominators in the top part of the complex rational expression, and how we can get rid of the denominator in the bottom part of the complex rational expression. So much like the work we did before, when I see I have a plus 1 here and I have a minus 7 here, I'm going to go ahead and multiply the top and the bottom by the same thing. Basically, I'll multiply the top and bottom by both of these. So it's going to be a plus 1 times a minus 7 over 1. The bottom will be a plus 1 times a minus 7 over 1 here. So this is going to help us to get rid of the fractions once and for all. Let's see what remains when we do this. Here we can reduce this a plus 1 with this a plus 1. And here we can do this a minus 7 with this a minus 7. Only by multiplying both of these. By including the a plus 1 and including the a minus 7 can we get rid of the denominators in both parts of this. So that's going to leave us now with a minus 7 over or times a minus 2 divided by a plus 1 over a minus 6. This fraction is now expressed in the simplest form, and that is as far as we can go with that question. So, a couple techniques. The first technique we need to bring to bear to simplify this as much as we can is to simplify the numerator of the complex rational expression and the denominator of the complex rational expression by factoring and simplifying as much as we can as we did here. Once we get to this point, we need to get rid of the remaining denominators in both parts of the complex rational expression, which we do here, and we get this form. One more question. before the first part of the video is over with. We're taking a look now at question 27. So we have the quantity of x over x squared plus 3x minus 4 minus 1 over x squared plus 3x minus 4 divided by x over x squared plus 6x plus 8 plus 3 over x squared plus 6x plus 8. So another technique we can try to see if we can work toward trying to simplify this is to see if there's any work we can do in the bottom to help simplify. And let's see, did I mark? I want to make sure I put that down right. 27. Yes, I did. Okay. For some reason, I think they may have put the wrong thing in the book. But let's see what happens with it anyway. So I'm going to go ahead and combine like terms in the top. So I don't have two fractions. I only have one. They have a common denominator, so I can do a little work by just writing this as x minus 1 over x squared plus 3x minus 4. And the bottom I can write as x plus 3 over x squared plus 6x plus 8. So what we want to do is see if we can do any simplification of the numerator or of the denominator. So I'm going to go ahead and I'm going to make some space below to see if that's going to be possible. So I'm going to take this first part, I'm bringing this over here. Well, x minus 1, I can simplify it all. However, I can write x squared plus 3x minus 4 as x minus 1 times x plus 4. So when I look at this now, I see, hey, I can reduce these x minus 1s, and that's going to leave me with simply just a 1 on top. So now I can write the numerator of the complex rational expression as 1 over x plus 4. Next, let's take a look to see if there's anything that can possibly be done with the denominator. I have a feeling they may have put the wrong number in the book on this, but I'm going to go ahead and go with it anyway and see what happens. So here I have x plus 3, and here for x squared plus 6x plus 8, these two factors are going to be x plus 2 times x plus 4. Nothing simplifies at this point, so I'm just going to go ahead and bring it over in factored form. So now we've got x plus 3 over the quantity of x plus 2 times x plus 4. At this point, what I'm looking to do is to get rid of the denominator of x plus 4 and to get rid of the denominator of x plus 2 times x plus 4. So I'm going to multiply the top fraction and the bottom fraction by x plus 2 times x plus 4, and that's going to keep that up here. So the x plus 2 times x plus 4 over 1, and then x plus 2 times the quantity of x plus 4 over 1. By doing this, for these two denominators, x plus 2 times x plus 4 is the least common. Again, if you feel like you need to write this down in separate steps, please go ahead and do so, because this is getting more complicated. So let's see what we can reduce. Well, I can reduce x plus 4 here and here. And here I can actually reduce the whole of the denominator in this part as well. So on the top, we are left very simply with x plus 2. Nothing else. On the bottom, we are simply left with x plus 3. And in fact, yes, that's the solution to the book, so that's what they had in mind. This whole fraction that we saw here originally as part of this huge problem simplifies quite nicely into x plus 2 times x plus 3. I encourage you to watch these videos a few times, as there's a lot of steps to digest, and there are a lot of little tricks that we have to look forward to coming in the next video.